So welcome again to the Nanton Aviation Station, Season 3, Episode 5. And today we're going to be standing the spar up on end so that we can do some drilling. And basically this is going to more or less finish up all the drilling for this, this phase. So maybe describe what we've been doing for the last week or so and what we're going to be doing next.
Okay, basically we've just been drilling off the trusses into the upper and lower spar caps so that we have a completed section. Now what we're doing is this surface right here, which is the top of the spar cap, we're going to be drilling that and putting in splice plates to solidify the whole top section. After that, we're just going to roll it over again, and this is the bottom, and do the same procedure. And that will finish off this operation and we have a completed spar.
So we have a little bit of machining and a little more drilling. There's some end fittings that we haven't quite, we have some decision making to make, but more or less we're more or less done. And then after that, splice plates are connected and we'll have to disassemble everything, label all of the parts, and then start painting all the components and get them ready for reassembly at some point. So hopefully we'll be able to carry on with the project. There's some funding that's going to be required for us to carry on, and a couple of decisions, but basically we're at the 95% point of this phase. So things are going really well. I've made some really good progress last week, by the way. It was very well done. So let's flip this puppy over. So the Halifax bomber, what was its gross wartime weight?
65,000 pounds, fully loaded.
So this component that we're turning today had to carry, in essence, that whole load.
It had to carry the whole load while it was on the ground, because this section and the rear spar, which we have over here, plus the ribs, that was the main basis for the whole airplane. Because it was a modular airplane, all the parts were bolted onto that, and then you had the intermediate wings, the tail planes, and all that stuff. Yes, but once the aircraft took off and started flying, well, the fuel tanks and all the weight in that was self-supporting at that point. So that didn't come into play anymore. But essentially on the ground with all the bombs, you know, oil, full wet weight was 65,000 pounds. And just think, compared to that, nowadays they're launching F-14 Tomcats that weigh that much off 309-foot deck. So, you know, there's a lot of technology difference now, but this is still the cool stuff.
Yeah, I mean, you know, it was cutting edge for the day,
oh, yes, it was.
right? Yeah. And you know, the fact, what always amazes me is that how they started off in, say, 37, 38 with interwar technology, and by the time 43, 44 came along, they had made such improvements. Went from rag and tube to stressed monocoque construction. You know, the materials development, engine development. You know, when you look at what they were flying in 1937, you know, Bristol Blenheims or Beauforts or whatever, yeah. And you know, string bags, swordfish, you know, to 1943, 44 when Halifax is, you know, really started to reach their maximum capacity. In such a short time. Yeah. It just amazes me, you know, how they did that.
Well, you know, it's like everything else nowadays. I'm sure there was a lot of industrial espionage going on, you know, stealing American information and, you know, French, German, you know, because they all had their own ideas and different technologies of doing it. Mm-hmm. And so basically at the end of the war, you know, they scooped up all the different airplanes and took the technology. But yeah, they kept developing all this stuff, and it was very interesting.
The adaptability always amazes me, especially, you know, in terms of radar development and things like that. I remember my father talking about having to learn new equipment almost every month. You know, again, you know, they'd, you know, acquire an airframe, say from the Germans, and then reverse engineer the technology and develop either countermeasures or new aggressive technologies, and it had to be put into the training syllabuses, and all the crew had to get up to speed in a very short time, and that translates into airframe, engine development, you name it. In some cases, this stuff was maybe shared, say, between the U.S. and Canada and Britain, but it was, as you say, very much stolen in other cases, right?
It was definitely stolen. Now, these are the splice plates. These are just temporarily bolted together to make sure that all the holes are symmetrical and line up. Because as you can see, there's a big chunk of metal there. And this is about 1.25 inches thick that we're going to be drilling through. And so that stack is about 5 inches, close to it, that all the holes have to line up perfectly straight.
Do you have a mic on right now?
Yep.
Now, as you can see, these are the upper splice plates. They go on top. These guys, they go inside. And then there's huge bolts that go all the way through to tie all this together. And the same thing will be on the bottom. Because we have to flip it one more time once this is done.
To get it to get it to splice down here.